Hello everyone. Already we have studied the various advantages of three-phase connection over single phase and the various type of connections, that is say star connection and delta connection. We have do the comparison between the star connection and delta connection, from where we can easily write the various short note on star and delta. Now, the another important part is that is the AC power supply system. That is, initially at the starting of the module, I have explained that the electric power is produced in the power stations, which is located in far away from our home or the consumers, from the industrial area or the that is the consumers or the locality, the residential area are far away from the generating stations. So that the generate from the power need to transmit from the generating stations to our home or the industry. Okay, it is then transmitted. So the generated power is then transmitted over the large distance to load centers with the help of conductors known as transmission lines. In the government area of the Kolkata or the city, we can easily see the various long transmission towers where the high power is being transmitted. And finally, it is being distributed to our large number of small and big consumers through the distribution network. So from there, you can easily understand there may basically two parts. First one, generation. Second one, transmission. And the last one is the distribution. Okay. The large network of conductors between the power stations and the consumers. So try to understand the transmission between the power station and the consumers can be broadly divided in two parts. First part, transmission system, and the third one, distribution system. Okay. After generation, the power, how it is coming to our home or the consumer, it is divided in two parts, transmission system and the distribution system. So each part can be further subdivided into two, that is primary transmission, secondary transmission. Similarly, primary distribution and secondary distribution. Clear? That is initially primary transmission and distribution. Second part, also it is both divided in the two part, primary transmission, secondary transmission, and primary distribution and secondary distribution. Now look at the diagram. The first part. Okay. The first part. The first thing is generating station. See, the at the upper level, the first one is generating station. So here the electrical power is being produced by three-phase alternator. Clear? In this generating station, the electrical power is being produced. The usual generation voltage is 11 kV. Clear? The usual generation voltage is 11 kV. Now the question is why it is 11 kV? Because 11 is the easiest number, which is multiplied with the form factor. Already we have studied in the module 2. That is, everything need to, the average generated voltage need to transfer to the RMS value. And the ratio is known as form factor. So this is everything is multiplied by that 1.1. Okay, so it is in the range of 11 kV. For economy in the transmission of electrical power, the generation voltage is stepped up to 220 kilovolt and more at generating station with the help of three-phase transformer. Clear? So what is happening? At the generating station, we used to generate the power at 11 kV, and this 11 kV is being stepped up to 220 kilovolt or more. Okay, this 11 kV is being stepped up. Already you guys have studied the step up transformer. We are stepping up the voltage, means the amount of the voltage is being increased, but the current, the corresponding current will decrease. Here we are increasing the voltage level so that the current will also decrease. That's why the conductor width, the area of the conductor rather, the area of the conductor will reduce. Try to understand. Here the generated voltage is 11 kV with some amount of high current. That current is having, the conductor area is higher. To reduce the transmission cost, we have increased the level of the voltage so that the level of the current being reduced. Clear? And if the current is reduced, then the area of the cross-sectional area of the conductor will also reduced. That is our objective here. Now the next part is primary transmission. So what is happening from the generating station to another substation, it is being transmitted. The electric power at 220 kV is transmitted by three-phase 3-wire or three-phase 4-wire overhead system. Mostly for this purpose we are using three-phase 4-wire overhead system. The primary transmission line terminates at the receiving station and which usually lies the outskirts of the city. Clear? This part means the after generation it is known as primary transmission because from that generating station it will come to the outskirt of the city. Clear? Where it is being stepped down. This 220 kV is being stepped down to 11 kV or 132 kV or 66 kV. Not 11, it is either 132 or 66 kV. Clear? So the after primary means at the time of primary transmission, at the end of primary transmission, we are stepping down the voltage. Here at the end of primary transmission, we are stepping down the voltage. Next is secondary transmission. So from that primary transmission, after the primary station, it will go to the some receiving stations. Clear? What happened there? At the receiving station, the voltage is reduced to 33 kV or 11 kV. Here, at the end of secondary transmission, it will again step down to 33 or 11 kV. 33 kV for the purpose of industry or the high consumers. Okay, industrial purpose, 11 kV for the residential purpose. Clear? At the end of secondary transmission, we are reducing the voltage level. Either it will be 11 kV or 33 kV. That is the 11 kV for residential purpose and the 33 kV for the industry purpose. Okay. From this station, the electrical power is transmitted to various substations located at the strategic point in the city. Okay, so after the primary transmission, the power will come to the outskirt of the city, and from the outskirt it will go to the main city, that is the internal city, means in the load center. Now here it will start the distribution part. Okay, some parts condition, that is the primary distribution. After the secondary distribution line terminates at the substation where the voltage is reduced from 33 kV to 11 kV, and the 11 kV lines run along the important road light sides of the city. Now already we have entered into the city, the power has entered into the city, and just we can see that some overhead lines are passing to the by the roads. Clear? The 11 kV lines run along the important road sides of the city. This forms a primary distribution. Big consumers having demand more than 50 kilowatt. Big consumer means industrial purpose are generally supplied power at 11 kV or 33 kV also for further handling at their own substation. So where the power consumption is very high, there the power is being directly transmitted, that is the 11 kV is being directly shared to that part and they need to handle their own power. Here, next, the starting of secondary distribution. So what you understand by the secondary distribution? The electrical power from the primary distribution line, that is 11 kV, is delivered to the distribution substations located near the consumer's locality. Okay. Now, in the small area in our locality, we can see the small transformers from where the power is coming to our home. Clear? The electric power from primary distribution line local area, which is being distributed to the local area located near the consumer's locality, and step down the voltage to 400 volt, three phase 4 watt for secondary distribution. The voltage between any two phases is 400 volt, and and between any phase and neutral is 230 volt. Okay, the single phase residential lightning load is connected between any one phase and the neutral, whereas the three phase load is connected to the three phase lines directly. Clear? So this is the end of the secondary distribution, and at this end we are used to take the secondary, means single phase connection to our home, and the three phase connection to some small industries. Clear? Or to handle more power. This is about the AC power supply system. Just a small recap. Here we are having the generating station. We are generating the power at 11 kV, 11 kilovolt. This 11 kilovolt for the transmission purpose, long distance transmission purpose, we are stepping up to 220 kV. This 220 kV will end at the end of primary transmission, and this will be the starting of secondary transmission. So in the primary transmission done by in the range of 220 kV. Now the secondary transmission is work on the range of 66 or 132 kV. Clear? And after that secondary transmission, it will again step down to 11 kV. This 11 kV again being comes to the outskirt of the city, and out from the outskirt it will come to the load center, where we can get the 11 kV directly for the high consumers, that is more than 50 kilowatt consumers, and for the local consumers or a home we used to take the single phase connection. Either mostly we are in our home, it will be single phase 230 volt. This is all about your AC power supply system. We are dividing it in some part, that is generation, transmission and distribution. The transmission is again divided into two, and distribution is again divided into two, and finally we are getting the power at our doorsteps. Clear?